approaching the second anniversary since the James Webb Space Telescope was launched. Its first 20 months of scientific work have changed how we see the universe. But it's also bringing up big challenges for scientists. The telescope is showing differences in our ideas about the universe. We're not sure about the exact time when the first star groups formed into the early galaxies we see now. Cosmologists thought this happened gradually in the first few hundred million years after the Big Bang. However, the James Webb Telescope's discoveries are making us rethink these ideas. Our current ideas suggest that these early baby galaxies grew up around 1 to 2 billion years after the universe started. They started small and then merged together, sort of like how young kids grow up to become adults, forming galaxies like our own Milky Way. Before this, we thought there was a time called the Cosmic Dark Ages. We imagined that the universe was covered in a fog made of neutral hydrogen that stopped the light from the first stars and galaxies. According to what we thought, this fog disappeared about 1 billion years after the Big Bang, allowing stars to form into galaxies, thereby slowly changing the universe to what it is today. That is what our models stated, almost all of them. Then the James Webb Space Telescope was launched, and we faced a major challenge that might change how we understand the universe. This telescope discovered thousands of super bright galaxies, some similar to our own, which surprised astronomers a lot. It made them question their basic ideas about how the universe changed over time. These galaxies shine so brightly that they should have grown to enormous sizes in a short time after forming during cosmic dawn. Ordinarily, a galaxy's brightness correlates with its size, but these galaxies emerged so soon after the Big Bang that there hasn't been enough time for them to grow this bright or large. This has perplexed scientists, leading to the term too big and too soon for these galaxies. Their brightness suggests they should have as many stars as our Milky Way, but they formed much quicker than expected. This puzzling situation prompted scientists to reevaluate the basic principles of cosmology. To unravel the mystery behind these galaxies' peculiar brightness, researchers turned to a supercomputer. They recognized that human understanding has its limits in such a complex scenario, so they sought technological assistance for a comprehensive investigation. The goal was to decipher the unusual radiance of these galaxies and understand how they defied the expected norms of cosmic evolution. This challenge led scientists to delve deeper into exploring these galaxies and reconsidering the established principles of how galaxies form and evolve. The researchers built a model to understand how galaxies form, using supercomputer simulations. These simulations recreated the complex interactions of gas in the early universe, showing how it merged to form stars, eventually giving rise to galaxies. By carefully considering factors like the universe's mass, energy, momentum, and chemical makeup, they proposed a possible explanation. Their proposal suggested that stars during this early period might have undergone sudden, intense bursts of formation after periods of quietness, termed bursty star formation. This process differs greatly from the steady birth rate of stars seen in today's universe. The researchers believe this unique mechanism might explain why the early universe appeared extraordinarily bright. They inferred that the bright galaxies spotted by the James Webb Space Telescope in the universe's infancy might be the result of these bursts of massive star formation. This could explain their higher brightness compared to what was expected for that time. In simpler terms, when the Webb telescope started observing the universe in 2022, it immediately found highly distant galaxies. These galaxies, seen when the universe was less than 400 million years old, appeared much brighter than what the standard model of cosmology predicted for that era. This led to doubts about the standard model, which suggests galaxies start small and grow through merges caused by dark matter in the cosmic web. Scientists now think that a galaxy system doesn't have to be super huge to emit bursts of light during star formation. This explains why we see many extremely bright galaxies. The results from the new computer simulations fit with the idea that galaxies grow in a hierarchy, like the standard model of cosmology describes. But the issues with this standard model go beyond this. The James Webb Telescope is revealing significant problems with the models. First off, it's finding galaxies very early in cosmic time. Normally, we believe that galaxies didn't start forming until about 1 billion years after the Big Bang. But the telescope has discovered fully formed and massive galaxies way earlier than that. For example, the oldest galaxy we've found using this telescope, Macy's galaxy, existed when the universe was just about 390 million years old. That's incredibly young in the grand scale of our cosmic history. And there might be even older galaxies waiting to be discovered. Secondly, scientists recently found evidence that two massive objects collided very early in the universe. This contradicts what cosmologists previously thought about when and how galaxy collisions happened. The James Webb Telescope is challenging this idea again. These two massive galaxy clusters combined to form an enormous cluster when the universe was only half its age. According to our model, that's way too early for such events. This new cluster, called the El Gordo Galaxy Cluster, is causing a big problem for the Big Bang theory. The standard idea was that galaxies formed first, and then they combined later on to create bigger galaxies and clusters. But El Gordo's appearance in cosmic history challenges this sequence, suggesting that these events occurred much earlier than expected. There's a big question ahead. Does this early massive collision suggest a new model, or changes to the current one? Another point. Near the birth of the universe, the James Webb Telescope spotted young galaxies that appeared as tiny red specks. Surprisingly, many of these galaxies showed swirling storms in their centers, indicating the presence of numerous sources scientists didn't expect to find. These storms, like tornadoes, could be caused by massive black holes, ancestors of the supermassive ones that appeared unusually early in the cosmic timeline. By studying these exceptionally young black holes discovered by the Webb telescope this year, scientists aim to understand how these colossal black holes emerged and whether they grew extremely fast or were simply born massive. However, these observations puzzle astronomers because they anticipated finding many smaller, voracious black holes. Instead, they discovered a series of hefty black holes that might challenge our current theories about how stars and galaxies form. Moreover, the Webb telescope found something else. In addition to the extremely massive early galaxies, it revealed that these galaxies didn't contain as many heavy elements as expected. Previous instruments couldn't reach far back enough in time to see this disparity in the chemical composition of galaxies around 11 billion years ago. But the Webb telescope's power allowed scientists to look back nearly 12 billion years, showing a difference in the relationship between star formation, mass, and chemical content. The Webb telescope is set to continue operating for a decade or two, offering more intricate details about the universe's origins. These findings could answer many lingering questions we currently don't have the answers to. What are your thoughts on these discoveries? Feel free to share your valuable comments, and remember to subscribe to Science Fellow for more updates.